the oil and gas industry is ever-changing. Partnering relationships between companies to reach goals have been developed to produce positive outcomes for everyone concerned. This team effort has led the industry to the doors of the world leader in the highest quality subsurface safety valves. Baker Oil Tools manufactures and services a wide range of downhole products from plants in Broken Arrow, Oklahoma and Aberdeen, Scotland, where together over 1,000 people are employed. Baker Oil Tools is an organization consisting of people and products providing solutions for completions, workovers, and fishing. In this program, we're going to concentrate on one of those products, the T-Series metal-to-metal safety valve and its accessories. The T-Series is a design which offers clients the latest developments at lower costs. It's tubing retrievable with a field-proven flapper-type closure mechanism and twin metal-to-metal seals on all its housing connections. The model is significantly shorter than old-style safety valves, and thanks to technological advances, it's much simpler and much more reliable. It's controlled through a single hydraulic line. As the pressure is applied, the fluid fills the hydraulic chamber. Since the system is closed, the increasing pressure pushes on the piston, which is forced downwards. The movement is continued through a coupling which attaches the piston to a flow tube. Below the flow tube there's a flapper, hinged at one side and held in the closed position by a torsion spring. On its upper surface is a machined concave recess. The downward pressure of the flow tube forces the flapper open. Simultaneously, it compresses a power spring. With the valve fully open, fluids from the formation string can flow up through the tubing string to the surface. If the control line pressure is reduced or cut off for any reason, the flapper will close automatically. With no downward pressure to hold it, the power spring forces the flow tube and the piston back up. As the flow tube moves clear of the flapper, the torsion spring lifts it back to close off the flow once again. As we said, it's a valve which operates on very simple principles, and thanks to the care that's gone into designing its features, it offers much greater reliability. We mentioned the twin metal-to-metal seals on the housing connections, for example. They're unique to Baker Oil Tools and much more reliable than ordinary single-step metal-to-metal seals. The same is true of the two dynamic seals on the piston, which are there to prevent any leakages of fluid or gas between the hydraulic chamber and the well bore. They're made not of elastomers, which absorb gas, but of thermoplastic. It's a much more reliable material, and in both the open and closed positions, there's extra backup for them, this time with a metal-to-metal full open and full closed stop seal. Although the flapper is essentially just a hinged lid, there are two types available for standard applications. There's a wedge shape, and for slimline applications where the external diameter of the valve is smaller, they can be saddle-shaped like this. Both are equally effective and equally reliable, and both can also be fitted with this self-equalizing feature, designed to simplify and quicken the opening procedure of the valve. The flapper is fitted with a plunger. Normally, the plunger is held closed by the pressure from below. As the flow tube moves down, however, it engages with the top of the plunger before it actually reaches the flapper itself. Depressing the plunger opens a pathway for the gas or oil to escape from below. When the pressure is the same on both sides of the flapper, the flow tube can push it open. This spring then closes the plunger again. The through-the-flapper self-equalizing feature is patented by Baker Oil Tools and has been used successfully in the North Sea for over 12 years. By simplifying their safety valves in this way, Baker Oil Tools have not only found more efficient and more elegant solutions to downhole problems, they have also reduced the number of things that can go wrong. But the wellbore environment is never entirely predictable, and if a problem does arise, there's still a need for accessories which can solve the problem without having to bring the whole tubing string back to the surface. That's why Baker Oil Tools stocks a full range of accessories for all their T-Series valves. If, for example, a tubing safety valve wasn't functioning properly, another means of closing the wellbore would have to be found. That's why this tool was produced. It's an insert valve. It's designed to be lowered on wireline and, as its name suggests, inserted into the tubing safety valve. The problem here, though, is we've only got a single hydraulic control line, which is acting directly on the closed system in the safety valve. So how are we going to activate the new valve? The answer is to adapt the original control system by breaching it and creating a different hydraulic chamber which will control the new valve. This is what's known as a communication feature. To activate the feature, a punch-type communication tool is used. It's designed to be lowered into the well on wireline, and, quite simply, to punch a hole in the wall of the safety valve so the original hydraulic system can communicate with the new one. Once again, its design is unique to Baker Oil Tools. Before the company introduced it, a quarter of all failures on tubing retrievable safety valves used to be in the communication feature. That was because they used to operate by having a sliding sleeve, which needed to be jarred open to give access to the hydraulic chamber. It was, of course, natural for the sleeves to be sometimes shifted by accidental jarring, so that the closed system was breached when it shouldn't have been. In this tool, there are no internal sleeves. As we said, it just requires a hole to be punched in the control chamber. It is more reliable, but will only work if the operator takes active steps to make it work. There is no question of it being activated prematurely. So, how does it work? Well, it's lowered on wireline down through the tubing string until the shoulder up at the top comes up against what's known as the no-go. That's a shoulder at the top of the safety valve with a smaller diameter. As its name suggests, it prevents the tool from going any further. When that happens, the operator knows the tool is in the correct position. There are two mandrels, inner and outer, and they're held together by a set of shear screws. By mechanically jarring down on the tool, the inner mandrel is forced downwards and the screws shear, so the inner and outer sections can now move independently. As the inner section continues to move downwards, dogs are forced out into a specially cut profile. They'll hold the outer mandrel in place. Down at the bottom of the outer mandrel, there's a block with a tungsten carbide penetrator projecting from it. It's sitting in an angled slot, and as the downward motion continues, the block is forced upwards till the penetrator is pushed right through the wall of the hydraulic control chamber of the safety valve. The communication tool can now be retrieved. Pulling it back up simply reverses the whole process. The penetrator slides back, the dogs retract, and the tool is brought back to the surface. There's one more thing to do before we run the insert valve into place. The flapper in the safety valve can still move. We could push it out of the way by lowering the new valve onto it, but that's not a very neat or satisfactory way of dealing with the problem. So instead, we'll use this tool to lock it open permanently. Its rather unimaginable name is the Flapper Lock Open Tool. Like all the other Baker Oil Tools products, it's designed to operate very simply. Basically, it's going to take a strong steel tube down to the flapper and then let it go, so that it opens out and pushes the flapper back against the housing of the safety valve. The tool holds the lock-open ring by gripping it in two sleeves at the top and bottom. The tool is lowered on wire line till it locates on the no-go. Jarring downwards forces the dogs out to lock it in the nipple profile. The inner mandrel is removed from the tool, initially forcing the sensing dogs outwards, ensuring the flapper cavity is free from debris, and then allowing two sets of dogs to drop inwards. This releases the two sleeves, which are forced away from the lock-open ring by power springs. As they clear each end of the lock-open ring, it springs out from the two and creates a lining around the flapper cavity, with the flapper held back behind it. The flapper lock-open tool is then retrieved. The design of the lock-open ring system ensures there is no restriction to the tubing or the valve when in place. The insert valve can now be lowered inside the safety valve housing till it locates on the no-go. When it's in position, there are two sets of chevron packing which seal the gap between it and the old valve's housing at the top and the bottom. This means that a completely new control chamber has been created. As pressure is applied, the hydraulic fluid moves down the line as before, but now it's forced through the hole we punched and into the gap between the insert valve and the old tubing valve. It can't escape through the top or the bottom, and so it's forced into the control chamber of the insert valve. Pressure is now acting on the piston of the insert valve. Continued pressure forces the flow tube downwards, pushing open the flapper and compressing the power spring in the insert valve just as the flow tube did in the original safety valve. The well bores open and the reserves can start to flow to the surface again. All this simplicity is a bit deceptive. It's taken a lot of complicated design work and exhausting testing procedures to produce tools which will give predictable results in all types of wells, time after time. But it's been worth it, because in Baker Oil Tools T-Series valve, the industry now has an extremely reliable, low-cost tubing safety valve which is thoroughly field-proven. That's not an idle claim. It's supported by statistics and the depth and quality of our client base. Up to now, over 5,000 of these valves have been sold worldwide. Simply stated, all the major companies in the industry have standardized on this valve. In the end, it's proof that reliability and simplicity produce the dividends that everyone's looking for.